Alright, today we're talking about a bunch of different things. We're going to talk about range, which you should know already. We're going to talk about IQR. We're going to talk about variance. Talk about standard deviation. We'll talk about percentiles. Hey guys, you talking while I am doesn't really contradict, or really contradicts learning. So like when I talk, you should be listening, unless you're contributing something to what I'm saying. So, like I said, we're talking about range. We're talking about inner quartile range. We're going to talk about standard deviation, and we'll also talk about percentiles. First of all, range. Used to describe how widely the data set varies. Maximum versus a minimum value. Right? You should know this probably from like 7th grade on. You know what the range is. You take the biggest value, subtract off the littlest value. Quartiles are values that divide the data into 4 equal parts. Quartiles sound a lot like quarters, right? 4 equal parts. There's 4 quarters in a football game. There's 4 quarters in a dollar. Divides into 4 parts or 4 quartiles. All right. The reason that we're introducing inner quartile range and maybe not just using range is because sometimes we get outliers in our data set, right? Sometimes numbers are way bigger than everything else or way smaller than everything else, and the range really kind of gets thrown off by those. You get some really big ranges then. Inner quartile range, we're going to talk about in a second, is going to tell us basically the range of the middle half of our data. So it's going to get rid of all those outliers. It's going to give us the meat of our data, tell us how spread out it is. So the inner quartile range, otherwise known as the IQR. So the inner quartile range of the IQR is the difference between the upper quartile and the lower quartile of a set of data. Sometimes you'll see it written as Q3 and Q1 for upper and lower quartiles. Sometimes you'll see UQ as upper quartile, LQ as lower quartile. We'll talk about what those actually are and how you find them in a second. But the difference between those two, so take the upper quartile, subtract the lower quartile to find your IQR. Alright? We all have that written down? Any questions on it? Alright. So, erase that. Finding the IQR, upper and lower quartiles are the medians of the upper half. You'll notice between the lower quartile, the median, and the upper quartile, that's what splits our data into 4 even parts. So to find our inner quartile range, or to find our upper and lower quartiles, the first thing you need to do with a set of data is you need to find its median. So if I look here, I look for the median. A lot of times you'll see me put a box around the median. Right, just so I know that's the median. Okay? So I'm going to put a box around the median. What happens then to find my lower and upper quartiles is I'm going to take the set of data above the median and the set of data below the median, and I'm going to find the medians of those 2 pieces of data. That'll give me my upper and my lower quartile. So my upper quartile is the median of the upper half of data from the median. Lower quartile is the median for the lower half of the data from the median. So in this case, 29 would be my upper quartile, 18 would be my lower quartile. Does that make sense? Right? Splitting it into 4 even parts. So then to find my IQR, I would take 29, I would subtract 18, I would get 11 as my IQR, my inner quartile range. Okay? Yes? No? Any questions? Should we try a problem? Okay, let's try one. First problem, it gives us the ages. I don't want that. What is that? Ages of riders on a roller coaster. Bunch of different ages. It says find the range and the IQR of the set of data. First thing I should do, what do you think it's going to be? Well, before I can even find the median, I need to do what? Put it least to greatest, right? Order them from smallest to largest, least to greatest. Then I'm going to go ahead and find my median once I have that done. Be careful. A lot of people, when they make a mistake on the test, they literally make it by when they're writing things up from least to greatest. Because they forget numbers. Right? Make sure you have all the numbers. Easy way to do that. Count how many you started with. Count how many you wrote out. Once you have them listed from least to greatest, find your median. Now be careful, I wouldn't just start like scribbling them out, crossing them off, because you're going to need them to find your IQR, right? So if you want to cross them off, just make sure you can still see what they actually are. I'm going to underline mine so that I know I used them already, but that way I can still see them. So I'm going to put a box around 21 and 21 because I have an even number of data points, which means I'm going to have to take the average of the two middle spots. Well, what's the average of 21 and 21? 21. So my median is 21. Now, is this my median? This exact data point? No. Is this my median? No, my median is actually in between the two of them, right? So when I go to find my lower and upper quartiles, I'm going to include those two middle points because they're not technically my median. If it's just one number, then it is your median, so you don't include it. Right? My median is technically in between the two of them, so I'm including them in the upper and the lower halves of my data. So now once you have it, now you can start crossing them off if you want. 19 is my lower quartile of my Q1. 24 is my upper quartile or Q3. So my range, take the biggest value, subtract the smallest value. 45 minus 16 gives me 29. My IQR, my upper quartile or 24 minus my lower quartile, which is 19, should give me 5. Right? So the range, it's kind of really spread out. Right? It tells me the whole set of data is between 29 different numbers. The IQR tells me that half of my data is between 5 different numbers. All right, so I mean that middle half of my data is all bunched together between 5 different numbers. Yes?
When would you need to know that?
When we're trying to figure out like how spread out something is. So, like you're saying, like if we're talking about like ages of racers in a 5K, right? Sometimes people want to see how wide that range is, so they'll use the actual range. But then you think about it, if you look at all the ages, you might have one person that's like 82, and everybody else is at like 40 to 45. So the range gets way thrown off by it, but the IQR wouldn't be. It would tell us that most of our runners are between 3 years of age instead of 45. Does that make sense? So it's kind of telling us where the meat of our data lies, how spread out it is. Okay? Does that make sense? Okay. Try the second one. On your own?
Yes.
If you're having troubles, raise your hand.
Yes.
Ask a question. How are you doing? Good, all smiles?
Yes.
Need more time? Alright, if you don't need more time, please check your answer with mine on the board. Right? Order them least to greatest. Find the median. Our median is in the middle of two numbers, so it should have been about 25.49. Then we need to find the upper and lower quartiles to find the median of that lower half and upper half of data. Same thing, take the average of the two lower ones, we get 19.99 is our lower quartile, our Q1. We get 34.49 for our upper quartile, our Q3. Take the range, biggest number minus smallest number, you get 25. Upper quartile minus lower quartile, you get your inner quartile range, well, 14.5. Any questions on that? Not too bad, right? Good talk. Alright, next we're going to talk about then is percentiles. So percentiles are like quartiles, except it splits our data up into 100 equal pieces. Right? Quartiles split up into 4 equal pieces, percentiles split up into 100 equal pieces. Now do not worry, we have a formula for it. You don't need to find the median 100 different times. Right? So, percentiles measure the position from the bottom. Does anyone know any instance in your life where you deal with percentiles? Class rank tells you your percentile, right? So you're like this 80th percentile. We like state testing, standardized testing. A lot of times they tell you what percentile you're in for certain different subjects. Hopefully everyone's in math is always telling them they're like in the 98th percentile or something like that. Right? That means that 98% of people are at or below you. Right? So that means you're better than 98% of the people that take that test. So, wow, words are really tough. Percentile is really telling us how many people are at or below us. How many people are we better than, basically. Alright? So, you're the 4th tallest person in a group of 20. 80% of people are shorter than you. That means you're going to be in the 80th percentile. Right? That means that 80% of people are shorter than you. Now, once again, percentile is measured. It tells us what percent of the total frequency scored at or below that measure. I can't stress this enough. At or below. Can't stress that enough. At or below your measure. Percentile rank, percentage of scores that fall at or below a given score. Right? That's what we talked about with those standardized tests. You get percentile rank, or even in your class rank, it tells you what percentile you're in. That means how many people are at or below you. Now, to find the percentile rank of a score X out of a set of N scores, what you do is you take the number of scores at or below X. So if I give you, like, say, 35, you take anything at or below 35, and you divide it by the total number of scores there are. So the number of scores at or below X divided by the number that there are, or N, times 100. Because we want to get it up to a whole number. Because what that'll do for us when you divide it gives a decimal. We want the whole number. The percentile should never be above 100. It should never be above 100. It can get all the way down to 0 if you're the last person, right? So if you're really not good, no. Alright. Let's try one problem. The scores for students are as follows. You can read them out. What is the percentile for a score of 71? So the first thing I'm going to do when I look at this problem, and in my brain, how it works is I'm going to circle everything at or below 71. Now, do you have to do that? No. But that's how my brain works. So anything I see that's at or below 71, I'm going to circle. And what I'm going to do is I'm going to count all those scores. How many times did I circle it? Well, 1, 2, 3, 4, 5, 6, 7. Over the total number of scores. Well, there's 10 scores. So 7 over 10 times 100. My final answer should be the 70th percentile. Do not write percent. We're not looking for a percent. We're looking for that percentile rank. Yes?
Do you have to write percentile like on the gun? Can you just write per?
I would say if you write 70th, I'll be okay with it. But just don't write 70%. Because the percent is different than the percentile rank. Okay? Does that make sense? So if you write 70%, it's going to get marked wrong. 70th percentile. Okay? Try the second one, please. Talking about scores. At or below 61. Percentile for a score of 61. Okay. Cool. Did we all get that? If we're, well, I guess if we're done working. Do you all get 50th percentile?
Yes.
Percentile rank's pretty easy, right? At or below. At or below. Okay. Sweet. So, next thing we're going to talk about, last thing we're going to talk about today, standard deviation. So, standard deviations measure how spread out numbers are. Right? It's based off of the mean, figuring out how spread numbers are away from the mean. The symbol is the Greek letter sigma. Almost looks like an O with a tail on top. Right? Sigma. I'm really terrible at drawing them. You'll probably not be good at it either unless you practice it a lot. But that's the symbol for standard deviation, okay? Now, standard deviation, formula is super easy. Square root of the variance. Well, what's the variance? If you're in engineering class, you've probably done this before. Variance is defined as the average of the squared differences from the mean. So you work out the mean for each number, subtract the mean, and then square the result. Then you work out the average of those squared differences. So, like if we're given this set of data, 600, 470, 170, 430, and 300. Find the mean for those numbers, subtract the mean, square them. Right? Subtract the mean, then you square them all. Then find the mean for that set of data. You get 21,704. That's your variance. Standard deviation, that is taking the square root of that. That's not on your paper though. Right? Neither is a formula for standard deviation.
Sure.
No,
You're going for